Alright, so I'm trying out this new software and I want to make a video about how to solve Hess's law problems. So Hess's law basically says that if we have a chemical reaction, or let's say we have a combination of reactants that produces a product, that the enthalpy change for the reaction is independent of the process that it takes to get from the reactants to the products. So, we can have some other reaction pathways, maybe that produce product A, that has a delta H A, and then some other reaction turns product A into product B, and there's a delta H for that reaction, and there's a reaction for product B that produces the product that we are desiring in this reaction, and there's a delta H, let's call that C, that basically delta H A plus delta H B plus delta H C equals delta H for our reaction. This delta H. So it sounds somewhat confusing, but the basic idea of Hess's law is that it doesn't matter what pathway you take. To get whether we take the direct pathway like we had here, or we take this more circuitous pathway like this, if we end up at the same place, the sum of the enthalpy changes ends up to the same enthalpy change. So let's try a example problem. Alright, so here's an example problem. Find the enthalpy change for this reaction. PCl5 gas, one reactant, it's a decomposition reaction, producing phosphorus trichloride gas and chlorine gas. And we don't know delta H for this one. But we've got two known reactions that are defined here. And what we want to do is look at how we can combine those two reactions to give us the same products, same reactants and products that we had in the initial reaction. So the first thing I'm going to look for is, do I see this reactant anywhere? And I see that's also a reactant in this reaction. How about the product, PCl3, that shows up in this reaction? And the other product, chlorine, also shows up in the first reaction. So I don't need to reverse either one of these reactions here. They would both add up to the product that we wanted. We're basically the products of this first reaction, or the second reaction, are going to be the reactants in the first reaction, and we should be able to combine those together. So let's try adding the two equations. So if we add them together, what we're going to get is 4PCl5, 4 phosphorus pentachloride, plus P4, and I'm letting the states out just to save space, although you're really supposed to include them, plus 6 moles chlorine gas, Cl2. So that takes care of the reactants, and then we can add products. We're going to get P4, that's this product, plus 10 Cl2 plus 4 PCl3. Now then we can eliminate, or that is cancel out, any substance that appears on both the reactant side and the product side. So I can see that phosphorus, P4, appears here and here. I'm going to cross it out. PCl5 only shows up on the reactant side, PCl3 only shows up on the product side, so they're not going to cancel out. But I've got 6 chlorine gas here, 10 chlorine gas here. So you can subtract basically and just see what the leftover is. So these 6 here are going to cancel out 6 of these here, so that's the coefficient changes to a 4. So then we kind of clean it up and we have 4 PCl5 decomposing into 4 PCl3 plus 4 chlorine gases, which is the exact sum of these two reactions added together. So Hess's law says we should just be able to combine the enthalpy changes and get the delta H for the reaction. So if I add up negative 2439 kilojoules and 3438 kilojoules, I'm going to get delta H for this reaction of 999 kilojoules. Now, if we look back at the original reaction, we can see that this reaction is reduced to lowest terms. In other words, they've divided out the coefficients here, which we need to do as well. But the 999 kilojoule enthalpy change was for the decomposition of 4 moles of PCl5. So to get the decomposition of 1 mole of PCl5 into 1 mole of chlorine gas and 1 mole of PCl3, we would just take the 999 divided by 4, which gives us an enthalpy change of around 250 kilojoules. So it's sort of a combination of using a little algebra, adding the chemical equations, and then just doing some arithmetic to figure out the enthalpy change for the sum of the reactions.